All right, example number 1. We need to evaluate the integral of x times sine x dx. Folks, the name of the game is making the correct choice. If you don't make the correct choice, then either you end up solving but with a lot of pain and suffering, taking the long road to get there, or you cannot solve at all. Okay? So what happened? You give it a try, and if it's not, then you switch, you choose. Basically, you have a choice of either to choose x as u and sine x dx as dv, or sine x as u and x dx as dv. How will you choose the correct one? This will come with a little bit of experience, and at the end of the class, I'll also give you an idea or a little roadmap as far as how to choose u and how to choose dv. But let's start by gaining some experience. So I'm going to choose u and dv. Now, why am I choosing this? Because if you look at the rule, we need 4 players in this game. We need u and v, and we need du and dv. Okay, so of x sine x dx, the dx will be part of the dv, right? So whatever I choose for v, at the end of dv will be dx. And I'm going to start by choosing u as x and dv as sine x dx. So underneath, I need to now to choose the u, and I need to, well, not to choose, I mean the choice of u and dv determine what will be du and what will be v. Well, du, since du dx is 1, then du equals 1 dx, so du is equals simply dx. The choice of dv equals sine x tells me that v is the integral of sine x dx, and I know it's going to be the negative cosine x. At this time, I just put the c aside, and I'll tack on the constant c at the end of the exercise. Okay, so here's what I'm going to do. Let me write the rule in red, and underneath the run, I'll write each of the components. So the rule says the following: the integral of u dv equals uv minus the integral of v du. Okay? I really recommend that you write it and you say it either with a silent voice that echoes in your head, or even say it aloud. This is sometimes the most rudimentary way to study, to memorize things, is the way they taught us in grammar school. Just say it several times until you remember it. In this case, I have no better advice, but repeat it to yourself: the integral of u dv equals u times v minus the integral of v du. You do it like 3-4 times, and it starts occupying some otherwise empty space in your head. All right, so this is in black now. U is x, dv is sine x dx. So this is the given function. U times v is x times negative cosine x minus the integral of v, which is negative cosine x, and the u is dx. Okay? Now, let me kind of rearrange it a little bit. So we have negative x cosine x, and here I have double negative, and I have plus the integral of cosine x dx. Now, this is an easy integral. We have that already as a sine x plus c, so the end result would be negative x cosine x plus sine x plus c, and I can write it, I can leave it like that, or I can write it as sine x minus x cosine x plus c. Okay, I want to check if really this result, if I differentiate this result, I'll get back x sine x. Sometimes we forget this basic thing that we can do to verify the correctness of our solution. So let's differentiate this, and we have cosine x, and here we have minus, and I apply the product rule, so it will be 1 times cosine x minus x times the derivative of cosine is negative sine. And of course the derivative of c is 0. So let's see, we have cosine x minus cosine x plus x sine x, and it's x sine x. So let's now try to solve the same example by choosing a different u and dv. Okay, so in this case, we're going to let u equal sine x, okay, and dv will be x dx. And I don't know if you can see from here what will be what will be the consequence of this choice. But let's see, du will be simply cosine x dx, but v will be now the antiderivative or the integral of x dx. So it will be x squared over 2 plus, of course, c. Okay, so again, let's write the rule. The integral of u dv equals uv minus the integral of v du. Underneath, we'll write our result here. Okay. Since u is sine x, I'm going to write it slightly differently. So it will be sine x, and dv is x dx. Okay, so we have this u times v going to be now sine x, which is u, times x squared over 2, which is v, minus the integral of v, which is x squared over 2, and du is cosine x dx. So what happened is we are no better than what we were before, because now I have to do it again, except instead of x sine x, I have x squared cosine x dx. So we can solve this integral. Let's see, can we? Now, if we go this route, we're going to continue, and x, the next time around, we'll have x cubed over 6. The next time around, we'll have x to the 4 over 24. So this is a poor choice. So we can write, and it is evident that this was, or this is, a poor choice of you